Hello, everyone. Welcome to the community call today. We are really excited to have you here with us. And so we're going to get started. Let me go through a few things. If this is your first community call, just some logistics real quick. So feel free to chat away on our YouTube or on our Discord general channel. If you aren't already on our Discord, the link's right there. Please join us and feel free to ask questions there or after the community call as well, because our speakers are in there. So they're happy to answer anything if you have some thoughts afterwards. And if you watch this community call and you'd love to present on it, please let me know. I'm on Discord all the time. So just DM me. I'll be happy to add you to the schedule. Okay, then also some quick reminders of events. So Jeremy from our team is actually going to be co-hosting the webinar today. He's going to be on a webinar with Octeto. So they're one of our partners, and we're really excited to show how to best use Dagger and Octeto together. And then we also will be at Pulumi Up. Jeremy will also be there too. Lots of events. And he's going to be showing how to best use Dagger with Pulumi. And we also have a community member who is based in Portugal. So he's going to be at two of the Portugal events, the DevOps Portugal, and then also Kubernetes Day in Portugal too. So very, very excited to see some representation of Dagger over there. And today we have Kambui Nurse with us. I'm going to update the layout so we can add Jeremy in here to talk with us. But very excited, Kambui, to have you here and to walk through this today and see what you have to show us. So let's go into sharing your screen, and then I will work on updating the layout to add Jeremy. But you can get started.
Awesome. Pleasure to be here. My name is Kambui Nurse. I work for a company called Marshall McLennan. I work on the core API team and innovation team, where I'm an innovation lead. Pretty much my day-to-day job function is to build proof of concepts with new and emerging technologies. And today I'm going to be presenting on self-corrective agentic workflow. Sounds real fancy, but I promise it's very simple. If you have a loop or a circular process that somehow involves a large language model, you can technically call that an agentic workflow. And I've played with several different variations of agents and ways to implement agents. Um, which I won't go into on this talk. I think I wanna stay on target and talk about what we're here to talk about. So before we dig into that, I think by the end of this talk, people will have a good grasp on exactly how this workflow works and how you can implement something similar to do similar tasks. So um, first, before we get into that, yeah, everyone likes everyone likes a backstory, but first everyone likes a story. So it's story time. I was first introduced to Dagger. Let me make this full screen. About 2 years ago, a colleague of mine from our platform team came to me, and he promised that if I was to ever give a talk on this tech, that I would mention his name. So I am going to do that. But Brian Lorette came to me and was like, "This is exciting tech. I think could be a game changer." I'm like, "What do you mean?" He was like, "Well, it's this. It's like, you remember the guys who did Docker? Well, they have this new thing called Dagger." And I'm like, "Okay." I think the intro was exciting enough where I wanted to take a look and decided to do a POC. So I kind of pitched it to the team, and they were like, we were in the process of actually defining our pipeline for the core API team, and I think we wanted to evaluate if Dagger was a good fit at the time. The slide you're looking at is my Q file. This is when Dagger used to be Q files. So I spent the next few weeks getting spun up on Q and working alongside the Dagger team on the POC, which was quite exciting. And if you guys look at line 7 on this slide, where I'm bringing in that spectral dependency, that was actually written by Solomon himself.
That brings back memories.
Yes. And you can imagine my excitement. I think I was very new into that role in that position, and having a chance to work with Solomon and the team was quite quite exciting. So at the end of the day, we ended up with something that kind of looks like this, right? So again, we manage APIs. So we have deploy, get standards, lint test, unit integration, generate proxy, and build all the available actions. And back then, we didn't do Dagger call, we did Dagger do. We don't do Dagger do anymore though. So that's kind of where things got started for me. And I think at the time, we liked what we saw in Dagger. I think there was a lot of power there on the onset. So I think the decision was made to kind of like put it on the shelf and watch the technology as it matures, and mature it has. So I went on to focus on more generative AI solutions and POCs that involve some sort of generative AI aspect. One of the things that I've built, this is if you guys see the initial commit on this slide, this was on my birthday of last year. I'm a single father of two teenage boys, and I got inspiration on my birthday to do something, and I decided to do a VS Code extension. Now, the extension was, in essence, a solution that would generate using AI unit tests for developers, well, or for their code. Now, what a unit test is in essence, is code that you write to ensure that code that you've written to implement a feature actually works. And it's something that developers either do or don't do. It really depends on the culture in which you work in. So sometimes, you work in a culture where it's business facing and there's tight deadlines, and sometimes you don't really have time to write code coverage or code that actually tests your code that you're shipping, and you just kind of want to get features out the door. So this tends to feel like a chore in that type of environment, and it's really, really stressful for the developer at large. And then you have other environments like the one I'm in now, where you can't even submit a feature unless it has coverage, right? Which, at least the the that part of your job is given priority, so you feel as though you can actually have time to implement that. But developers work in both of those types of cultures, and you can go from one to the next in a few years if you change role, in essence. But it's something that we all have to do. It's something that kind of makes us feel confident about our code. So over the weekend, I implemented this test generation thing with AI, right? The tests were decent enough to get developers going, but the experience wasn't the best. So uh, all in all, it took about a weekend for me to build the initial POC, and then we had a look at it at work on the following week, and there was some excitement around it, but I think it was really lacking in features and the user experience. Also, is was really the solution was tied to like the VS Code editor. Now we're a large organization with over 85,000 employees and about roughly 5,000 developers, and they're all using different editors. So does that mean that we develop an extension for each editor? Think about how expensive that would be to maintain, and just consistency amongst editors and extensions. So I think we went back to the drawing board. It was like, it was a good demonstration that generative AI is a tool that can be used to generate code, in essence, augment a developer's job. So the solution was, when we went back to the drawing board, was to tackle this problem from a continuous integration perspective, right? Because if we tackle the problem there, and continuous integration for the non-technical folks just essentially means that when you deploy your application, you want to ensure that it actually works. So you run smoke tests, you run unit tests, you run integration tests, you run all these things to ensure that when you ship that new feature, you didn't break any existing features. Therefore, you're integrating new features. So we call it continuous integration. The solution was this. So Uh, this is a diagram of the architectural. This is the architectural diagram of what I believe to be the solution to that problem, right? Um, whereby what I wanted to develop here was a CLI that worked by analyzing the developer's existing coverage. Well, as every time, let me show you guys what a coverage. I'll show you guys what a coverage report looks like shortly. But every time like you write a test, then that test is ran by a reporter, and then that reporter gives you a coverage report. And in that coverage report, it kind of outlines the areas in your code that require testing. Um, so I came up with the idea to why not use that initial report to get analytics on the code base in the form of a coverage report and then generate unit tests based on those coverage reports. So it has a plugging system. So if you are coming from any different language, you can, in essence, extend the functionality of this bot by writing your own plugin. So today we're going to demo the one plugin that exists, which is for TypeScript projects. As you can see in the slide right here, I have it, I'm calling it the Just Reporter plugin. But I do have plans to add a PyTest reporter plugin for Python projects. So the plugin, in essence, is responsible for parsing that coverage report and pulling out some key information, pulling out the code that actually needs to be coverage, pulling out the percentage of coverage that exists for that code. And then I want to bring your attention to the purple box where we actually define the self-corrective code agent. And remember, I said it's a fancy description, but really all it is a loop that involves an LLM. And as you can see, it's kind of the entry point to that is this generate node, where what I do is I send a request to the LLM to generate code. Then I get a code solution. And then what I want to do with that code solution is to actually check to see if that code executes without any errors. So if you kind of following along with the diagram, we have the check execution step. And what I was doing there in this POC was I needed a way to check code execution regardless of what programming language, I just needed a generic test harness, for lack of a better word. And what better than Docker to do that, right? We all place our applications inside of containers for deployment. Why not just spin up a container with the application and run the code? So that's exactly what I'm doing there. If the code executes and there aren't any errors, then we make a decision to commit the code or to do a git commit, saving that progress. If the code executes and we encounter some errors, then what we do, we go right back to generating another code solution. And there goes our loop. So we generate an initial solution, we check the execution contains errors, we feed those errors right back into the loop. Eventually reach an end condition, which in essence is the amount of iterations we want the AI agent to iterate over the code for. And then we decide to finish. And we create something called a pull request. Now, for the non-technical folks, a pull request is a way that developers introduce code changes into a code repository. So you create a pull request. Your pull request has like a list of files that represent change. Developers can then take that opportunity to discuss that change. That's a perfect opportunity for you to have a code review. And then once everyone's on board with the change, then it kind of just goes in. But there was a problem with the solution. I demoed it. It was everyone was like, "Oh, it's nice. This is great. I like it. It actually worked," which to see it work was actually great because you can see when the initial code generation goes in, one of the common errors that I was seeing over and over and over again, it was like the AI would generate the code, but it would have no idea as to where it was in regards to the folder structure. So when it's bringing in dependencies for the tests, it just got it all wrong, at least 100% of the time. But as you're telling it, hey, I can't find this file because the location that you're specifying that it's located and it's actually not there, by reinforcing those errors, it eventually will guess the right location. So that was one big problem. Um, I also had the problem of distribution. Like I built a CLI that runs a agent. How do I get this in the hands of other developers to test and play with? And that seemed challenging. And as you can see, part of my step, especially the code execution step, I'm using Docker. So when I launch my thing, does it need to go from a CLI to a service to be utilized by other developers, which was something that I was discussing internally? Or how do I get past the fact that I probably need to put my CLI itself inside a container or inside something, and then potentially run Docker inside of that? So those was getting confusing. And then I was like, I was looking at this, I was just staring at it. I'm like, okay, GitHub and Docker. There's something, there's something that I worked with 2 years ago that would just be perfect for this. And lo and behold, I introduced Dagger into the mix, and my life got immediately better. I reached out to the Dagger folks, and mind you, it's been 2 years since we've spoken. And I'm like, hey, I have this AI thing that I'm trying to do, and Dagger at its very basic level is a distributed CLI in essence. So I was like, I think that's going to solve my problem. At least it's going to solve my distribution problem. But not only did it solve that, it actually made the solution much better, much nicer, and much cleaner, allowing me to remove the lang graph dependency, the lang chain dependency, and the lang Smith dependency. And as every developer knows, if you're able to delete code, it's the best refactor you can possibly have. It removes complexity, and it just makes your life easier. One of the things that I've noticed from the very onset, and this is even before we got things working, and kudos to the Dagger team for just hopping and just pairing with me. I mean, I even got a chance to pair with Solomon again. And I think it took us all but a week to get Dagger plugged into the solution. And I'm going to illustrate today exactly how that looks. For the technical folks on the call, I want to dive deeper into the code. We'll have opportunities to do that as well. But one of the things that I realized right on the onset is that I got an increase in performance. Dagger, you get. Can someone jump in here and help me with the caching that Dagger does? But what it does, you have that caching at the Docker layer, but you also have that caching at the execution layer. And then you also have optimization at like when you write your procedural code, Dagger then translate that into an execution that it does to optimize what you're trying to do. So there's some optimizations there as well. So I was like, wait a minute, this thing got faster. I also got utility in my plugin system because Dagger has these types where I can just specify a just-in-time artifact, meaning my configuration for my plugin, and it all just works. Like I had the plugin architecture there, but I didn't really, I really couldn't conceptualize how it would work in production with this. I mean, I have a distributed CLI that I can just pass a file to. So that was like alarming. And then the number one issue that I was getting with the code generation, where the AI wasn't able to like figure out where it was in regards to my application directory structure, became a breeze working with the Dagger API, because I can simply just, you in essence get a variable that represents your application, and you can do wonders with it. So I can ask questions like, where am I, right? A simple Unix command to figure that out, add that context to the AI application, and boom, I'm getting the right test generated the first time around. So without further ado, enough of the technical. Let's get to the demo. Anyone have any questions in regards to those slides? Anyone want to interject anything? Jeremy, Solomon, anyone?
I'm sold. I want to try this Dagger thing.
All right, so let's jump right in. So what I'll do now, I ran this earlier because I wasn't trying to come up here and run it and have it not work. So what I did was I have some PRs that I generated this morning, right? Which we can look at, right? But we're also going to kick one off live. So this was 3 hours ago. Um,
And Kibo, you got feedback in the comments that you have a fan. Someone likes the way you explain the problem.
Okay, awesome. Thank you. So I will kick off the workflow, and I'll talk through what we're seeing in the logs. Now it's going to iterate through. Let's first of all, let me set the stage here. What I'm going to be doing is generating unit tests for the extension that I wrote a year ago. So this is the extension that I wrote a year ago. And here's the coverage report for that extension. So this is kind of what the plugin does, right? The plugin is responsible for reading this coverage report and trying to figure out, okay, where do I need to focus my attention? And as you can see, there's 6 files here that aren't like 100% coverage. So we have this code lens provider, this command.ts file, this just runner config file, this utils file, and this test generator file, and all 6 files, right? And what the plugin will do is, as it goes into each file, and this is what developers read, right? When they're trying to, I mean, it's a metric. It's not the end all be all of, is your application stable, but it's definitely something that people look at, right? And just because you have 100%, there's a caveat here. Code coverage doesn't actually mean that you have tests that are, actually testing the functionality. So don't be fooled by that. But as you can see, I'm not getting full % coverage because it's highlighting this line that my current test will never hit this line. It's basically what this is saying. But 96.42% of this file is covered by my tests, which gives me confidence as a developer. But if you look at this one that's a little bit more amber, we go into that one, you're going to see a lot more red, right? You're going to see red there on line 109. You're going to see red there on line 59. So what we want the solution to do is identify these gaps in coverage and generate some unit tests for us, making the developer a little bit faster, augmenting something that, he may perceive as a chore, depending on the environment that he's in. So let's run it. Let's kick it off. Enough talk. All right, so let me kind of talk through this Dagger call, the function, and the arguments. So I'm doing Dagger call, and because I'm in a directory that has like a Dagger, I'm in a Dagger project, I can kind of just call this thing. But if I wanted to give this to another developer to call, I could literally just point him to the GitHub repo where this is hosted. But for purposes of this demo, I'm just going to run it from where it was built. So we're doing Dagger call generate unit tests, which is our only function. We're passing in a configuration. We're going to take a look at that in a second. And then we're passing in a GitHub token, which is private, which we're not going to take a look at. And then we're passing in the URL, and that's the URL of the VS Code extension that we're going to generate tests for. We just had a look at the coverage. And then we're passing in a Docker file path. That Docker file path is the path to the Docker file within that project. Okay. Let's take a look at the config file before we run this. It's going to come up while it's running, but I kind of want to take a look at it just so you guys know, like, what the configuration kind of looks like. So we have configs for the reporter, and here we're specifying that we want to use the just one. And again, if you were to write your own plugin, hint, developers out there that want to help me extend this thing, you would specify that plugin here. The command line on line 4 is basically the command that is going to be used to generate the coverage report. Then some directory paths that are kind of associated with that coverage report. So we have the report root directory, the report directory, and where we can actually get the test results, because the plugin's also going to be responsible for parsing those test results. And then here on line 10 is the model that we're going to be using. And there's a little treat for you guys, because rather than focus on the slides, I wanted to focus on more code and functionality. So I included OpenAI's new structured response within this demo, so you guys can take a look at that code if anyone's interested. It was also beneficial in helping me delete a lot of unnecessary dependencies that I had on LangChain as well. And then we have the test generation configurations. And what I'm saying here on line 12 is that I want you, AI, to try and generate For each file, you have 3 iterations to see if you can get it right. Again, if you increase this, the bill is going to go up. If you don't leave a max iterations, then it can run forever. Because what if it just keeps running into errors? And we don't want that, because that's a big bill at the end of the day. The test directory that the tests are going to be basically created in, because when you have test coverage, you kind of have to specify that as configuration. The working directory for the container, this one's a kind of code smell, but Solid and I are working on fixing that, right?
Yes, sir.
All right, and then the test suffix. So now let's
and Kambui, that's the kind of file where you'll generate a PyTest version of that or any others that you need in the future, right?
Correct.
Yeah. Nice.
I see someone's paying attention. All right, so let's run it. And the Dagger engine kicks off, right? What's really happening here is that because I'm running Docker desktop, Dagger is using that.
You can press plus to see more detail on what's going on, by the way.
Yeah.
For like downloading something.
What is it? Yeah, it's installing the module. Okay.
It's kind of surprising it's taking so long.
Yeah, there it goes. Okay, so there it goes. So so Dagger does assist with secret management. As you can see in my GitHub token, it's grabbing the config file from the host, right? And then it's running that entry point function, generate unit tests. My secret's all obfuscated, so no bad actors can get access to that or to these logs. The URL that I want to generate tests for, so kind of printing out the configuration so you can see it as it's running. And this is the amazing part. Like now it's just kind of running and dynamically bringing that application, putting it inside a container. Here we have the 11 reports. So these are 11. This is the code coverage we just saw, but the terminal version of it, and it's ranked those files based on their lack of coverage. So it's probably going to attention the just runner first. And first thing it does, it executes the test command. So that's what it's doing now down here, so that it can get the initial coverage. And lo and behold, it generates its first test with a first error, right? So we have a first error here that says it tried to generate a test.
So now we feed back in Kambui.
Exactly. Now we regenerate with that feedback. Now, one of the cool things here is that I was using LangGraph to define my agent runtime, and it was kind of like competing with Dagger's efficiency that you get from Dagger just out of the box. And you get that efficiency out of the box by just writing regular code, which is also cool. So this is the product of that. Just a faster running solution. So we're gonna let this run because it's gonna iterate for 6 files. It's gonna iterate 3 times for 6 files, and we're gonna kind of look at the end result. And I'm gonna take questions while this is running, and I'm gonna show you guys what it looks like when it's all finished. And then hopefully, at some point at the end of this talk, we're actually going to see the pull request live, right? So we don't really have to sit here and watch.
I love it. I mean, and this is the Kambui. This was that point when you first reached out recently.
Mm-hmm.
You had kind of all this working, but like you said, you had your custom CLI that would call out, and then it would pull down some things. It would run some things in a Docker container. Then you're saying, but I need another container for the environment to run this in. So how do I do a Docker in Docker? And then wait, where does all this stuff live? How do I distribute to developers and all of that? And I mean, now what you've come up with here, you can just, I mean, I think you just showed it. You can run Dagger just from your terminal, even without having any of that code locally present. And Dagger will just pull it right out of GitHub, right? And you just, and set everything up from there.
Correct. Correct. Like, I don't know if the light bulbs is going off to any developers listening, but I mean, this pattern is powerful. I mean, today, all we're doing is introducing test coverage or code generation for test coverage, but we could easily adapt this same paradigm to analyze a code base and suggest refactorings, right? Sometimes to get better test coverage, you kind of need to refactor your code so that it's written to be more testable. We can also, since we have a PR, which in essence is a conversation with developers about change around an application, we can involve an AI into that conversation as well, right? Where developers can leave feedback on the PR and an AI can pick that feedback up and work that back into its process. I mean, there's so much potential here. I mean, you think about all of the obsolescence that we have to manage as developers as our applications age, having a way to kind of like put your application in a variable and do things with AI with it. I mean, I'm getting goosebumps thinking about that. There's a lot to unpack here, and there's actually a lot more potential. This is kind of scratching the surface.
And actually, a question came in. So one, that this is awesome, but so regarding the LLM part, is the LLM self-hosted, and does it have limitations with tokens?
So great question. The LLM is I'm using OpenAI. If you take a look at the config, that model in the config is an OpenAI model. It's one that supports structured responses. Let me show you the code that's actually making the call. So this is the code that's actually making the call now. I have my OpenAI token as an environment variable. It kind of makes this all happen, but this is like fresh. Like OpenAI released this structured response capabilities from the API weeks ago. And I refactored this just to kind of demonstrate it. So I'm basically saying I want the response, because when you're building applications, you need to get back a structured object. Here we're using a pydantic model to define that structure. And my structure is a code module. If we take a look at what a code module is, a code module is the code we're asking the LLM to generate, the imports to that code, the strategy. The strategy is kind of interesting because the LLM will fill out the strategy with what it think it needs to do to improve to test coverage. Because as you can see, I'm giving it descriptions here, and these descriptions serve as kind of like hints as to what I wanted to generate. The test path, and I was kind of using this to save the file, but I found a more consistent way to do that. But most importantly, if the code execution fails, a property to capture the errors, right? So if we go back to the generate thing and OpenAI's new functionality that allows you to ask the LLM a question and get back JSON. I'm telling it I want to get back my JSON in the response format of a code module, giving me code, import statements, a strategy, no errors because I haven't ran the code, but you kind of get the drift there. Does that answer your question?
There's one aspect of this that I'm really excited about that we talked about, because Dagger lets you split up the logic into individual functions and they're self-contained. You can start with one big function, but then you can split it up into smaller and smaller functions. And there's also support for abstract interfaces, right? So you can call a function and pass as an argument an object that implements an interface, right? And then you can pass any implementation as an argument, right? And you can do all of that cross language because we rely on the GraphQL type system. So I can call your function that's implemented in Python, and I could pass it an object that's implemented in another module written in Go or whatever. Mm-hmm. And in this case, one way we could use that feature, I think, is to abstract away the model, right? So I call, like right now you have a hard-coded or configurable through a string call to this or that OpenAI model. Mm-hmm. I could pass as your Dagger function an object that implements the model interface. Mm-hmm. And the function for that interface would probably be something like prompt, and it returns either text or structured data. And then if you make it optional, so if I don't pass an argument, you default to the current implementation, this or that model for OpenAI. But then if I want to play with another, a local model or another provider's model, one thing this ecosystem is doing really well is interop. I mean, the API is pretty simple, right? So it would probably be really pretty easy and also fun to just run the same thing with different models, and then you can have another Dagger function that fans out to a bunch of them and maybe benchmarks them or something.
Yeah, absolutely. I mean, the potential is big.
I would love to prototype that. That's kind of my next side project.
Okay.
Well, there's so many cool models to play with, right?
Yeah, absolutely. I mean, there's even areas where you can fine tune on the fly, right? And I think Dagger would make that trivial, right? You could, in essence, when I'm getting feedback from the PRs, I can gather that feedback, where I capture what the AI model generated, what the code that actually got merged, because the developer had to come in and say, nah, you got me about 85% there, but this 15%, I'm going to have to complete. And we can collect that over time, fine tune a model that's very specific to that repo. And I believe this all can be accomplished with the help of Dagger. And like Solomon said, creating a more generic interface so where, the model that you depend on for your solution is arbitrary. You can pass it in, you can pass it in there. So there's again, there's a lot of potential here. And I'm just shocked that no one's doing this with Dagger.
Well, it's starting. Yeah, I think it started out as a pure CI/CD tool, so it's not like we advertise on the website, come try building AI agents.
Okay,
Dagger. But I think, the community is definitely figuring out a lot of cool use cases. We're kind of all going in our little niches and applying Dagger to our whatever problems we have. Like a pipeline's a pipeline.
This is correct.
Yeah, and actually, a shameless plug. I'll put the link again on the chat for everyone. But if you aren't already in our Discord, it's a great place to be because that's how we found out about Kambui's use case. But everyone talks about their various POCs and things that they're doing with Dagger there. So it's really fun to brainstorm. And if you aren't already there, you'll see also these Dagger and channels that allow you to talk about various topics that go well with Dagger and other people who are using the same use case. It's always really cool to see everyone in there talking about the best practices for those type of things. So I'll put the link in here so you can go.
Yeah. I mean, any other questions? I mean, we have the PR that just got generated a minute ago.
Nice.
One question came in that was any thoughts on Daggerizing the internal steps that are currently referenced in the config file?
The internal steps that are referenced in the config file?
Yeah, for example, the coverage run or the generation step or
I see.
That that as like a separate module that could be triggered was the question that we got.
Yeah. I think that would be a nice refactor. I think so you can compose it, right? Is why you would want to do that. Yeah. I like the idea.
Oh, I have another question. Did you try the web view and the traces? When you press W while it's running.
I did not. Do you want to do that live or something? Do you have enough time?
We have time, yeah. I think there was another demo, but he got sick, unfortunately, so we got extra time.
Okay.
Then if there's more time, we can just add the swappable model feature live. We can just live code it.
I'll let you do that. I'm
Maybe we can find someone who wants you to use their model to contribute it.
Exactly. All right, let me see. I didn't sign up for this thing. Let me sign up. Okay, so now that I'm in the dashboard, do I just run it again?
Yeah, wait, go to dashboard.
Okay.
Just click on the button at the bottom, go to dashboard.
Oh,
Big blue button, yeah.
Okay.
So yeah, I have an account already. Okay, yeah, so now you just type Dagger login. Yeah, just type that command and you're good.
So is it real time? Like if I run it?
Yeah, so go to the terminal and press W.
W.
So normally it's going to start sending telemetry. And it's all only metadata, right? So it doesn't actually see your source code, your secrets, any of that. But then you can expand, see that you can just kind of unroll and see the details of what happened.
But this is the hello thing. I want to run my thing.
Oh yeah, just so run it again. Yeah, it's hooked up for everything.
Okay.
Boom.
Yeah, W. Oh yeah, or you can go to the list. You can list all the traces.
This is cool. So this is functionality I kind of lost because I was getting this from the LangChain tooling, but it's good to see that I also have it here.
Yeah, we're as soon as people started building really ambitious pipelines, pretty quickly we realized, okay, we need a way to visualize these because there's a lot going on, you know.
Yeah.
And especially when things are sometimes they're slow, you want to figure out, okay, what's slow exactly? Which part is slow? So you see the timing information, or is it caching properly or not? Stuff like that.
This is awesome.
Also, a good combo with the Discord server that Miranda mentioned. I mean, you know this, Kimbui, but basically the Discord server is for two things, right? Helping each other out and arguing over features, right? So the helping each other out part works really well. You just share a link to that run and you say, hey, I don't understand why this is broken. And then we collaborate on, we'll look at the run and say, oh, you forgot this or that.
Okay. Awesome. Any questions? Anyone want to
see any other questions?
Can we go through the code a little bit?
Yeah, are you going to open source it? How do people get access to the code?
So yes, well, Salim, you did agree to work with me and iterate on it, and then we'll open source it together. How about that?
Solomon, there is a question that came in.
I will daggerize everything. It's going to be so daggerized at the end, you won't even recognize it. There'll be Dagger everywhere. There will be no README. It'll be a Dagger function that prints the README.
Okay.
Future is now.
Be careful what you wish for.
Just for the recording, there was another question that came in. I think this might be for Jeremy Solomon. Does that mean a function can expose a structured input so that the different model can create a corresponding object and pass it over?
Yes. Yeah, there's a limitation in the CLI. The CLI doesn't know how to pass a structured object, but that's just a limitation of the Dagger CLI is just another client of the Dagger API. There's nothing special about it other than it's super fun to use. But the API supports it. I think the limitation is you can't. A module can define its own types, its own structured types, which is really powerful. So you can have custom artifacts, right? You can have an object that represents your application, and then you attach functions to that, right? And it modifies the state of your object. And it's all cross-language, so it's like object-oriented RPC kind of. So the limitation is you can't. If you import two different modules, you cannot write a module that takes as argument the type defined in another module. But that's where you use interfaces. You can have any number of modules that all implement the same interface in their own different implementations, and then they can all use the same interface. So you can set your own standards and have these standards adopted across your modules, right?
I want to explore.
Yeah. Interfaces. Honestly, I feel like we're not using interfaces enough. We shipped this like a few months ago, like a while ago now, but think it's another kind of incremental step in figuring out the power. Like, I think a few of us, even at Dagger, didn't fully realize what was possible. And then I remember having a moment like, oh, wow, wait, you can do that? We shift that? Wait, I want to use it more.
What are these icons here? What are these icons?
Oh, those are fun space and space.
So these are visual IDs. So every object that's produced, everything's content addressed, right? Everything's kind of immutable, reproducible. So every time a function returns an object, that object has a unique ID, a content addressed ID, and this is a visual representation of the ID. So it's these little space invaders. They're generated to be a visual representation of the ID. Yeah.
Whose idea was it to do Space Invaders?
Alex Sirachi.
All right.
Sirachi?
Give that man a praise.
Alex, yeah. Yes. He's also the creator of Concourse CI for the OGs who remember Concourse CI, a really cool CI system. We have a bunch of CI CD nerds at Dagger, and maybe unsurprisingly. we're pipeline nerds, like pipelines.
Yeah, it was some fun design work to get those. So
we got a feature request, by the way, from a Dagger user, and the request is to be able to click on the Space Invader for the ID you like and have it printed on a poster and sent to your home if you like it. Like print out your favorite artifact ID. These are artifacts. That's what they are. These are the just-in-time artifacts you were talking about.
Mm-hmm.
And then someone did have a question around does Dagger cloud tracing coming to the TUI soon? But I think we can see stuff from the TUI, right? It's seeing kind of the traces within the TUI.
Yeah, it's the same. It's those two are converging, so you can go back and forth between the terminal and web, and you see it's the same telemetry. And in fact, Alex, who's the lead on both parts, both the terminal implementation and the web implementation, is working on converging it more. We actually have an experiment that may or may not succeed, but I have a good feeling about, where the web version runs the same code base that renders in the terminal, but in the browser. So literally Go code running in the browser. And that should help us converge even faster. Because right now you have to kind of re-implement everything twice, right? Once in Go in the terminal and once in React TypeScript here from the same data. So it might start looking even more similar soon.
Hey, Kambui, did you see that Brian caught your shout out? Send some love back to you.
Well, let me give a larger shout out to all of the MMC tech.
Yeah, we got definitely got some fans in the audience.
Yeah, welcome everyone. We do this every other week. You're always welcome to join.
Yeah.
And the crew from the Rocco Academy said the TUI interface is super cool, and props to Alex for being able to implement it. So
yeah, seriously.
Yeah, this is it right here, right?
Yeah, this is it. But there's so many details, like the Vim bindings work if you like VI, like so you can GG to go to the top, capital G to go to the bottom.
Oh, I didn't know.
Actually, you can navigate. So if you press minus, you'll get less detail. You can navigate. So if you press enter on any one of those, you'll zoom in. And then if you press W there, you'll get the web version of that zoomed in part.
Oh, I like that.
So as insane as you think it is, it's more insane. And I completely agree with the Rock Code Academy comment that it's just very impressive engineering work.
We just need to put in some fish shell.
The Vim bindings with it.
Yeah,
some fish for you, Kambui.
My favorite part is that someone jokingly, when we showed a demo of this, someone jokingly said we should do Vim bind. You guys should do Vim bindings, and then turned out it was already done.
Of course, it was.
And then Patrick was talking about a Space Invaders game. So some fun facts of at our last team retreat, we actually the team actually made a Space Invaders game. So Kyle mentioned if you search for super technical invaders, you can actually kick some butt on some pipelines playing some games there.
That's the next demo. We're playing Amble Invaders together.
Absolutely.
All
Thanks,
right.
Kambui.
No worries.
It's really exciting.
To get a hold of me, I'll be available in the Discord channel, in the Dagger Discord channel.
Awesome.
Just ping me on there. If you have any questions or if you want a deep dive or whatever.
We'll need a demo of version 2, right?
Yeah, just version 2 is around the corner. What I want to do is write the plugin for Python and then have this solution be self-healing. So as I'm building it, it's suggesting PRs for itself.
Great.
so that's, I was like, wait a minute, that's actually possible. I can do that. So, I have this overall, this all comes from, I'm not gonna lie to you, selfish motivational purposes. Like I want to have these AI bots augment a lot of what I do when I do POCs, right?
Yeah.
Not just write code for me. Give me the first draft of something. Yeah. And then I come take a look at it and go, no, try again. So I'm hoping to get to the stage where I have several bots doing several things. So.
Well, thank you so much for joining us today and showing everyone. And thank you everyone who joined us for this hour, taking some time to learn about this stuff with us. We really appreciate it. We're really excited to see hopefully some new folks in the Dagger Discord too. We have an intros channel, so say hi there. Let us know that you joined today. Kimberly, you had some people loving your presentation. So amazing job, and thank you again for sharing your story with us.
No worries, no worries. Sharing is caring.
Awesome. Well, have a great day, everyone, and we will see you in 2 weeks. Bye.
Cheers.
Bye.